All right, let's get into something really interesting. We're going to uncover the hidden physics behind one of the strangest, but also one of the most serious commands in military history. It's a rule that almost sounds like an old wives' tale, but it's actually there to prevent a very real and pretty catastrophic disaster.
You've probably heard this before, right? Soldiers are literally ordered to break step, to stop marching and just walk like normal people when they get to a bridge. And it feels kind of weird, doesn't it? I mean, you'd think military precision is the whole point, but on a bridge, that precision is the exact problem.
So, what's this all about? Is it just some dusty old tradition, a superstition passed down from one generation of soldiers to the next? Or is there something else going on here? Well, as you've probably guessed, we're here to talk about some seriously powerful physics. Okay, let's start by just being really clear about what's at stake here. This isn't just a friendly suggestion. Nope. It's a critical safety measure because the consequences of ignoring it can be, well, let's just say they're spectacular and absolutely terrifying.
I know, it sounds impossible, but a group of soldiers all walking in a synchronized rhythm can generate enough force to shake a massive structure until it literally rips itself apart. The whole key is that phrase, perfectly timed. But how on earth is that even possible?
To really get how this works, we need to first look at the bridge itself. Because believe it or not, pretty much every object in the universe has its own secret beat. Nothing is ever perfectly stiff and rigid. Even things that seem totally solid, like a huge steel bridge, can vibrate. They have this natural tendency to oscillate, to kind of wobble at a very specific rate. It's a bit like a guitar string, right? You pluck it, and it always makes the same note. So in physics, we call this preferred wobble its natural frequency. It's the unique rhythm that a structure just wants to fall into if you give it a little nudge and then leave it alone. The key to this whole mystery is figuring out how that tiny natural wobble can be cranked up to 11. Let's use a super simple analogy. Picture yourself pushing someone on a swing. If you just give it random shoves at all the wrong times, what happens? Nothing, right? The swing barely moves. You're actually working against its natural motion. But if you time your pushes perfectly, matching the rhythm of the swing as it goes back and forth, well, then every little push you give adds more and more energy. The swing goes higher and higher and higher, maybe even to a dangerous height. You're using these tiny rhythmic inputs to create a massive result. And that is exactly what can happen to a bridge. Okay, so we've got the bridge with its natural frequency, its own secret wobble. Now let's bring in the other half of the equation, that force being applied by the soldiers. When a force gets applied over and over again in a really predictable pattern, we call that a periodic force. It's not random at all. It has a beat, a tempo, a frequency all its own. And this is where the danger comes from. You get hundreds of boots hitting the ground at the exact same instant, over and over again. That creates an incredibly powerful and consistent periodic force, just pulsing through the entire structure of the bridge. So here's where it all comes together. If the soldier's marching beat is different from the bridge's natural wobble, the forces are out of sync. Not much happens, the energy transfer is low, and the bridge is totally fine. But if that marching frequency just so happens to match the bridge's natural frequency, bam! Every single footstep adds energy in perfect time with the bridge's wobble, just like pushing that swing. The vibrations get bigger and bigger and bigger. This whole phenomenon of matching rhythms to create these enormous vibrations, it has a name. And it's basically the villain of our story. It's called resonance. That's the official term for what happens when an outside periodic force, like marching, lines up perfectly with an object's internal natural frequency. The result is a dramatic and often incredibly dangerous spike in vibration. So that's the big secret. It's not about how much the soldiers weigh. It's all about their rhythm. A perfectly timed march can accidentally become a weapon of resonance aimed right at the very bridge they're trying to cross. So how in the world do you defeat such a powerful law of physics? Well, this solution is unbelievably simple, but it's also kind of brilliant. When soldiers are told to break step, they just stop marching together and walk normally. Instantly, their footsteps become random and irregular. That one simple action totally destroys the periodic force. Without that consistent, repeating rhythm, there's nothing left to match the bridge's natural frequency. The energy can't build up. And just like that, the danger of resonance is completely gone. So yeah, that command to break step isn't just a tradition at all. It's a direct, life-saving countermeasure against resonance. It takes a synchronized, potentially destructive force and turns it right back into harmless, random noise.
Now that you get this, you're going to start seeing it everywhere. It's why an opera singer can shatter a glass with just their voice. It's basically how a microwave uses a specific frequency to cook your food. It's this fundamental force of our universe. So the real question is, where else in your daily life is this hidden power of matched rhythms at play?